Hello guys, welcome back to my YouTube channel. My name is Andrews, and in this video we are going to touch a little bit on still the services and the banners, and also check CVEs, and then finally wrap it up with to make our program faster. We wrap it up with some multi-threading or try to let things run in parallel. Okay, so one may argue that why are you doing this project? Isn't it a waste of time? Apart from getting my hands dirty and getting my hands wet on some of these things relating to networking and all those stuffs, I believe there are already great tools like Nmap. There's no argument about that. But if I am to be in a situation that I need to make some customizations to get something done that I can't do with Nmap out of the box, then at least I know where to start from and where I'm heading to. Okay, so let's continue. In the last video, we implemented, or in the last series of videos, we had implemented pod banner to grab the banners of the pods. Okay, and we also, for HTML or HTTP, we implemented a special pod banner for that, and we're going to do something similar for FTP too. So without much ado, I want to make some correction here, or I want to add something there to make sure that we don't get any errors or any problems. So assuming you have the string and you check if they are equal. In Python they are not equal because Python is case sensitive. So to avoid it, or we just want to know that ABC, that's it. We don't care whether they're uppercase or lowercase. It is advisable we use case forward, or you can better still maybe change all of them to lowercase, like a dot lower, and then compare them. Okay, and then that too is true. So I want to make that happen here so that we don't get such errors, or our program doesn't. If it happens that there's even H capital, then this condition or the original condition wouldn't satisfy. So that's that. Let's also create a special banner for FTP. Okay. Okay, so for FTP, you will need to import FTP library from Python. So import FTP library. We are going to see, let's call it FTP banner, and that will receive the IP and the ports. So we need to create a handle. Okay. And then we will initialize the connection as the IP and the ports. And we can also get the banner with ftp.getWelcome. Very simple. So the main reason why I want us to do this is not even about the banner. Let me call this additional info. Okay, so the main reason why I want us to do this is to check if the FTP port is acceptable to anonymous login. Okay, so there are times that they might be susceptible to anonymous login, so you can already get some foothold in the server. So we say that if we have the text successful in login, if that is the case, then what we are saying is let's go for banner. That's equal to just try to be vulnerable to anonymous login. Okay, right. So if it happens that we can just log in even without any password. Sometimes if you pass the username anonymous to it or something, it works, then it is susceptible to anonymous login. But if that's not the case, Yeah, let's just close the FTP connection that we created. And if there's an exception, just pass. Okay, so what we return will be the banner. Okay, so let's take it out for a spin and see if everything is working correctly. So there's a port banner function. Okay, it has to be. Let's start commenting some of this. The private IP and the ports. Alright, I hope it works without any problems. Okay, so of course we know it's vulnerable to anonymous again. There are a couple of things that have changed. In the previous video, when we implemented the port banner, we realized that we were getting the HTML content for the banner, and that's not what we want. We want just the information like maybe powered by or the server, what technology is powering the server. So we decided to implement a special function for web servers. So in the case that we have HTML or HTTP in the banner, we want to call this HTTP banner, which just implements it just requests for the website, and then we just fish out only the server from the headers. And then we've also implemented the very same functionality for FTP. We can move on doing the same for SSH and the rest, Telnet and all the others, but we'll just maintain just ATP, HTML, HTTP, and then FTP. Okay, so for the FTP, we move on ahead to check for uh, what we call anonymous login. So if we use the FTP library, so if you're able to establish a connection, we get the banner, and then we are able to log in without passing any username or password parameters to it, then it's probably vulnerable to anonymous login. And we just need this additional information for further uh, to help us in the next steps of the kill chain, to help us in trying to get some foothold in the target and do whatever we want to do, maybe uh, escalate privileges and move laterally and all that. So let's move on to implementing the multi-threading functionality. But to give us a quick, I've drawn this illustration here to help us give us some visual of what's going on. So assuming we have 100,000 jobs, we have tags, 100,000 tags, a pool of 100,000 tags to complete, and it takes 5 seconds to complete each one. Okay, for each worker it takes 5 seconds to complete the task. So assuming we have one worker, that means that the worker is going to take 500,000 seconds. I don't know how many minutes that is. If you divide it by 60, we'll get a minute, and probably another 60 we get an hour. So 500,000 seconds, that's quite a long time. And we want to finish this job very quickly. So assuming we had 10 or more workers. So it means we are going to divide this 100,000 jobs to the 10 workers. And it's estimated that we will spend 50,000 seconds. That is a very, 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 very significant increase or decrease in the time spent. Significant decrease. So that's very good for performance. So the more workers we have, the less time we are going to take to get the very same results. All right, that's all that we want to implement. Okay, so let's do that over here. For starters, let's call time that we are going to use to check how long it takes, and then let's import let's say import time, and then import. This is what we are going to use to create the workers and perform the multi-threading functionality. So assuming we have a task, let's use n for number of tasks, and then for each task it takes 1 second. Okay, it takes 1 second to complete that task, and then we return. Right, it takes a second for the task to complete. Okay, and let's create hmm, let's see, and then assuming we have number of tasks, we have 10 tasks to complete. So each person is going to work on one. So we say for I in range of the number of tasks. Okay, we want you to do the tasks. That's what we are saying. Let's take this out of here for now. We want you to do the tasks, which will take a second, and then yeah, that's it. Oh, I forgot to bring the column. And that's it. So let's check the time that it takes to complete this task. So say start time equal time, and then end time will be the same time. Okay, so we'll print out that it took, so we have end time minus start time seconds to complete. Okay, so we have 10 tasks to complete, and each task is going to take 1 second, so we are expecting it to take 10 seconds. Okay, all right, so it took 10 seconds. I think I should format this, but I'll leave it. It took 10 seconds to complete that task. So what we want to do is we want to implement multi-threading to ensure that it takes, if you have, assuming you have 10 workers, if you have 10 workers, then we want it to take probably, it will take a second instead of 10 seconds. Okay, so we are going to call the function that will implement the multi-threading, we are going to call that function speed. Okay, we're going to call that function speed. So we say that with concurrent the futures, so this function will create the workers. So we will pass the number of workers for the task. So let's say n over here. We will pass that to it and say as probably executor. Then let's create a container to contain all this. So we will say executor plus submit. Okay, we are going to submit the work to it, and the submit we will pass a function to it and some I travel over here. So what we are saying is for each of the jobs, submit this function, and the function will take in certain inputs, okay, which will be the number of jobs for you to work on. Let me show you an illustration here. Let's use this illustration here to explain it. So we have 100,000 jobs to complete or tasks to complete, and we have 10 workers. So it means that each worker must get 10,000. Each worker must get 10,000. Yes, must get 10,000 tasks to complete. Do you understand? So that's what's going on over here. So we will pass. So let's go to our trial and then take this. Oh, I didn't cut this. And then change a couple of things. Concurrent of futures. We need to import it. We need to import time, import concurrent the futures. Okay. And for this nice function, you include it over here. Okay. You import this guy from items. You import everything over there. Okay. Let's make this. Let's make this jaws to make it nice. Okay. And then we need the number of workers, which will probably be the threads. So in the argument processor, we will need to add another argument to it. So this will be for thread. The type will be an integer. Okay. And let's set the default to 20. So yeah, let's have the number of threads. Okay. So the workers are going to be the number of threads. So let's say the number of workers will be self dot ask dot threads. Okay. So that's going to be the number of workers. Why still not defined? I'll just define it over here. Why is it claiming not defined? Oh, because of this. Oh, yeah, right, right, right. Yeah. All right, all right. Okay, so we have that. We pass the function to it. And I think there's one particular thing that we forgot to include. Very important. That that would say uh, we want to wait for each of the job to complete first before we move on. Okay. And then probably what we are going to say is that we are going to return a list that will have I dot results for I in futures. So this is obviously just a list. So this is just a list. So we iterate to each of the results that we have and then just include that. So that's the only thing that we want out of it. Okay. I think our speed function is looking fine. It's just that now we need to go and solve some of the problems to avoid race condition. And if we also have to pass certain arguments to um, fix the problem of having too many workers than needed. Okay. So assume you have 1,000 threads. The user passed 1,000 threads and you have just 10 posts to scan. It doesn't make sense to have 1,000 threads for just for 10 jobs. So if the number of workers, ideally, if they are less than or equal to the length of the job or the number of jobs, then uh, just wanted you to miss Python. So yeah, if that's the case, then just divide it among the workers. But if that's not the case, then just let the length of the batch should be equal to, so each worker will just get one job Okay, so before we change some of these things, let's say there's a space for us to a couple of comments. Okay, for us to just do some things. And so let's say from Scapy dot or import star. Just pause this. So assuming we have this IP range or IP network and we have this number of ports, and then so it will mean that the scanning we will have to do times this is wrong. I should make this copy dot IP. That's the code. Okay. And a port range. So if you have this IP range and you have this 100 ports, it will mean that we are going to scan 1980 times. Okay. And we are going to scan each IP 100 times and all that. But there's one thing that you realize. Let's run this. Okay, let's run the first 1024 ports. Oh, we don't need to run it. Let me explain it. If you check it, run it yourself, you see what I'm talking about. If you can tell over here, yeah, over here, the number of ports that we have. If we have 1,000 ports, 5,000 ports, 10,000 ports, we try scanning everything together over here. And what happens is um, sometimes the timeout occurs before we even get results for some of the ports, and sometimes too we get few results for just some few ports. And assuming that whatever network we are scanning has IDS, intrusion detection systems, and intrusion prevention systems in place already using, I believe SynScan is very noisy already. So scanning so many ports at a go is not ideal. We want to scan one port at a time and all that. Okay, so uh, we will want to change that and scan each port at a time instead of scanning the whole number of ports at one at one glance or one go. It's not working or it's not efficient. So we need to find a way to, instead of scanning for each IP, scan 100 ports at once. You want to scan each IP and one port. So what I mean is this. So we want a situation where we have IP range. Let's make it a little sensible. I dot text for I and IP range. Okay, and then we will need one special. We will need to create another special function. I will call it IP pair. So IP pair. It will take X and Y. Okay, it will take X and Y, and then for I in X, and then for J in Y, it will yield I comma J. That's what I are saying. And okay, so let's print a list of IP pair where we passed the IP range and the port range. Okay, let's do this. Okay, not so nice. Let's reduce the let's reduce this to just 10. Clearly, run it again. Oh, this is bad. I placed it before the imports. Okay, Okay, so you can tell that each IP each IP is having its own. It's like we have a tuple of IP with a pause, IP with a pause, IP with a pause. You can see that going on. That's what we want. And then we will, for each time we submit a task, we will be scanning through them. Okay. Let's take this nice function and then place it among these beautiful functions. All right. We will change this. I didn't want to be going back and forth. That's why so far everything is in there. It's over here. We will change this. All this. So we have, we need to change this. We don't want it to be self the active IPs. We just want it to be active IPs. And then we will pass the active IPs to the, and we will pass not sell the ports. This is all just to prevent the race contradiction that I talked about, to make them private. They will have each instance, and then IPs and for, no, not over here. Oh yeah, nope, 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 nope. That's not what we want. Sorry guys. I'll call it IP ports. Okay, so this will take away IP ports. You'll find out how to get an IP port later. Alright. When we come to the speed function, we will implement the IP pair that showed you. I just showed you over here, the things we did over here. So if the port is none, that means you are doing port scan. So we want to change the way the jobs are. We'll make it I comma j for I comma j in the IP pair port function that we created. Oh yeah, jobs and the ports. Okay. Okay, so I hope you guys are not confused so far. Okay, so let's take a look at how we are going to make sure we call our post scanner. Let's comment it out without any problems. So active IPs, go to the keys. If you remember what we did over there, the keys are rather the IPs and the okay. So now we'll call our speed function. We'll call our speed function and we will pass the post scanner as the task, and then the active IPs will be in this case our job, uh, the jobs to be done, and the number of jobs to be done, and we will pass the ports, which will indicate this port is over here, which will indicate the that we are using the port scanner. And then, but before we work on the port scanner, let's make sure it works fine, and let's implement what I showed you guys over here in the speed function. So if we have if the port is none, then we know that we are using a port scanner. So we will say that job should be equal to the list for the IP port pair function that we had, and then it will take input of the jobs and the ports so that it creates the pairs that we had over here. I have changed it to IP ports. I have changed it to IP port over here, right? So IP port pair. So that's let's run it and see, make sure everything works here as we expect. Then later on, we will come back to the post scanner and then fix it up so that everything works very nicely. Okay. So let's take a look at the variables over here. You can see them. Okay. Pause the number of workers. Since we didn't pass any um, value to the thread, the default is 20 and we pass pause. So the jobs, so this is the jobs. Let's see. Okay, so you can see we have the IP pairs that we want. Nicely done. Since 20 is less than 1024, which is the length of the, we expect this to be okay. Let's create a breakpoint here and let this run. Alright, I'm expecting us to have errors upon errors. Let's go to, so you can see here we had attribute errors in there because we've not conditioned, but so far everything is good. We have the variables in good conditions to work with SB function. So now we just need to recondition the post scanner to be able to work with our input now. Okay. So from here, the post scanner will have a batch of IP pairs in a list form. Okay, so we need to deal with that. This will be, it will be, let me call it IP port list. It will have a pair of IP ports in a list form passed to it. And that's where we are going to get our active IPs. We don't need this anymore. Let's comment that one out. And then, so we need to remove this. This will be just ports. So say for IP, comma ports in IP port list, the list that we have here. We iterate through each one of them separately. Let's create a container to save all the results. We'll call it results. It will be a dictionary and IP. Okay, it will be a dictionary. Okay, so let's continue. So we'll have change the ports, ports. We don't need to now print this information anymore. So for each of them, it will kind of, okay, let's print them out to know what's going on. But it will be too much, it will be too repetitive. It's going to be annoying. And since we are not scanning the whole port together, we don't need this anymore. Let's comment that one too out. Things are becoming messy, I know. Okay, let's see. Obviously, if it is open, enter the cloud. Yeah, everything should still work fine, but we have to wait and check how we are going to put the results in that. Let's run it. It should be printing along. Let's run it and see how everything works. Okay, so it's working. Perfect, perfect, perfect. Obviously, some are taking longer, but it's working. It's kind of beautiful. This doesn't look so good. Well, let's stop it. It's working. We need to. Obviously, some are going to take quite some time, so we just need to change this timeout. Probably make it 3 seconds, and let's run it again. I need to remove this breakpoint. 1, 2. Okay. Is 30 seconds too long? Hold on, guys. Let me check a couple. I don't think anything is wrong with our speed function. Something might be going on in the post scanner. Let me take a quick look. And alright, guys. So there was one problem with our port banner. For some of the ports, the buffer that we were receiving was taking longer than expected. So I have placed a timeout here. 1 second. 1 second is even too long. It shouldn't take that long. But I made it 1 second. One second is too long in computing. Yeah. So I made it 1 second, and then that is it. Let's run it again. Hopefully everything works now perfectly. Yes, everything is working perfectly. And you can see our workers. Oh, yeah, that's up here. Our workers were busy working. So let's check. Let's use the map. Just do a quick scan. So we're expecting this post to be open 111.139, and I believe we have all of them. We have all of them working at a very fast rate compared to before. If we didn't pass this through, oh, we've already made changes. I can't go back. I should have timed it so that we could tell the difference, see the time as reduced. So sorry, guys. But if you're working on this, you can probably go back, undo some of things, and just use the time function we implemented over here. Not here. Yeah. We used over here to check the time, and you tell that there's a significant difference in the time spent with. I think we are done, guys. We've done it. Now, what we need to figure out is to stop these print statements and get everything in one big container. Get everything in one big container, as I showed you over here, so that we now sort them out and print them out nicely in some table form. And in the, let's see, let's do the terminal. Let's run it again so that I show you what I'm talking about. Okay, our workers, you can see the thread pools. They are busy doing their thing. Okay, so you can tell at this point we have 139 finishing last but one, but over here it was the last one, 445, 80, you know. So the ports are not arranged in descending or ascending order. They are all messed up because the threads are all finishing at different times. We are lucky. There could be some instance that maybe the thread working on 23 and 25 finished at the same time and everything will be printed on the same line. Okay, so we don't need to be printing them over here. We just need to collect them all in one container and just print them out nicely. Okay, so let's figure out how to do that and then continue from there, implement our CVE checks, and then we'll be done with this whole project. Hello guys, so I have finished implementing the printer function to print the results. Quickly take a couple of minutes and show you guys how it works, and then you can get the code, the GitHub repository in the description box. Okay, so as I explained earlier on, we needed it to be in a format that we can pass it to our multi-threading function, which is the speed function, and then for everything to work. So I believe I've already explained this. Alright, so here's the speed function. I've already explained everything that goes into it and how it works. So when we get the final results for each of the um, threads, then what we will do is we pass that to here. We will get the results over here, and then we will pass it to this function called table print that I have placed under the helpers directory over here. It's over here, printer.py. So yep, I pick up some data to be able to test it, and then let me use that to show you. It'll be very simple in that regard. So Where do I even start from? Okay, let's start from here. So we load the pickle data and then we call table print function this. Okay, so we call the sort and we start it. So if you remember, the data we have will be a dictionary and the keys were the IP address. So we passed the active IPs and the dictionaries to our final solution, which came over here. Okay, so this will be the active IPs, and we just want to create another dictionary where the active IPs are still the keys. And then for each data, okay, since it's a dictionary, we will have a key value pair for this. So for each key, we just append the resource in each of the data. And if we are to check the length of the data, okay, 51 because we had we passed 50 threads, and if we divide it, we had 1024 ports, and this was about 4 IP address, so you have about 4096 here. So we have 4096, and then we divide that by 50. All right, so you get each one, and I think that will, okay, so you get exactly 50 times each one will give you exactly 4050, remaining 46, which will be the additional, which will be given to another thread. That's why we have 51 data. Okay, so we just loop through them, and then at the end, let me just create a breakpoint over here. At the end of the day, oh sorry, it's rather, okay. So at the end, we will have a list where we have a dictionary where the IP address will have all the values that they had, all the results for that particular IP address, and then that will be repeating throughout. Okay, so that will be the structure of final our final results. And then for each IP, you will just print out the results. Let's put this over here, and then you realize, oh, what am I doing? Okay, let me stop this, clear this, and then let's run it without a breakpoints. Alright, so you can see that for this IP address, we had this results, the service, the banner, we created a table, and then we just added all the list in that key, in that dictionary, the values. Okay, this will be the data, which will be the values for that particular IP. We just added all the rules over here and then printed it out, sorted by this port number, right? And then the very same thing for the other one. So if there is no data, then we print out that the port has no data, and we use this to print out the colors. Very helpful function. Library, sorry. You could have some problems if you try running this on Windows, but with this function, it works almost everywhere. So far, I've not had any issues. So that's that, and then let's move on to the last step of the project, which will be the uh, CVE check. Okay. Hello guys. So we are done with the very first four. We are now left with a CVE check. Let's quickly do that. So we are going to use a function called we are going to use a library called Vulners, and so I'm going to make it in an object-oriented programming method because we will need to be validating the the APIs, and you need to put an API. You need to create a file called vuln underscore API. Place the API that we get from vulners.com. This is not a promotion video. It is the website that I was able to get an API. This is a login page. I'm not a robot, please. So this is the API that I could search for. I could get to send requests for checking for CVEs and the rest. I checked the others. I couldn't get it from ExploitDB. I think you have to pay some money, and they were very helpful. I reached out to them since I was using this for academic purposes. I reached out to them and they gave me and then an API for research purposes. I can share it with you guys. So you need to go there. I think they will give you an API that will have some limited capacity, but it will suffice to at least use it a couple of times. Okay, so let's quickly get into it. We will need to be validating the APIs. I already have some functions that I want to just copy and paste them so that we quickly finish the other projects and other tutorials out there. Currently, I'm learning from APSEC University on APIs. Oh, it just popped up. Where is it? From APSEC University, they have great course, free course going for API penetration testing and the fundamentals. This blew my mind. It really did, because you learn a lot of things about how easy than Baruch or not. Oh, I don't know if I've mentioned the name correctly. So it will open your eye to some of the possibilities that um, can happen with APIs, and yeah. Okay, so what this app function is doing is it will just open the one API that I talked about, this text, and then it will read the API. Obviously, it should be the only thing in there. So after that, but if it doesn't find the file, if there is an exception, file not found error, this will be the output. The program will come to an end. But if that doesn't happen, it checks and validates the API with this function, and then yeah, everything is fine. If not, you return false. If everything is fine, we return true. Okay, so um, then we will need. Oh, sorry, I posted it at the initial. I should have pasted it here. Okay, then we will. We will create another function that we will call scan vulns. Okay, I already have the code. Let me just paste it and explain it to you guys. Okay, so this function is going to be responsible for checking it. So it initializes it, and in the initialization, if the API status is true, then nothing will happen. But if it is false, this will validate to true, and then it will return. So what we will need to do is, okay, so we will have self.api status equal to, okay, the API validator. All right, and then after when it's done, this will mean that we have a list containing tuples, three tuples, okay, containing tuples of length 3. So with IP, port, and the text will be the banner that we will use to, we will send to the, um, we will send with the API for the result that we need. So we need to condition our, okay, so this is the last function. This is the last function that we use. I will pretty much want us to get the result from here and not go back to trying to figure out how to get it from here. So let's import our CVE check here and call the function directly from here. That is going to be a problem. So we import sys, and then we say sys dot then path dot append. All right, then we will append it so that we'll be able to import it. Okay, so yeah, okay, print working directly. We'll just copy this. Did I just, okay, paste that over here. Okay, so because the reason why we are doing that is because this CVE check is actually out of the printer API. Okay, that's why we are doing it. That way, so that we'll be able to, so you can call import CVE check. Let's say from CVE check import scan bonds. Okay, and then yes. So we will need to condition it so that we'll be able to get the results. But let's just run this. I want us to use this because we pickled some data so that we won't need to always initialize the scan before we can go on ahead. So I have some data that I've pickled, serialized there. I just need to load them up, and then we will use that to test it. After that, we will run everything. Hopefully there are no errors. So there are no errors with, there are no problem with the imports. Alright, and then okay, so there are no problems with the imports. So now we need to figure out how to get the data in the format such that we will have a list, and then each list will contain a tuple of 3 items. Okay, so yes, I think it will be ideal to implement it somewhere around here. So let's create a container for that. We will call it, let's call it CVE input. Okay, let's call it CVE input. It will be a list, an empty list. and then after printing it out, say CVE dot CV input dot append. So the tuple will need the IP, which will be the first thing, and then this is going to be very challenging because the data is actually a list of a list. Oh my god. Okay, we can get around the list of a list with this nice function from iTravel. Okay, so uh, let's do it this way. Okay, obviously, and then we will have let's say I let's say D in from iTravel. Oh my, from iTravel, and then you just pass the data to it because the data is actually a list of a list. It will just what it will do is if you pass two iterated or iTravels to it, it will just remove them and put them all together as one nice function. Very helpful. So what we do is oh yeah, this should be for D. For D in from iTravel, and then so for each iTravel will be an element with the first value being port, the second one being state, service, and just like that. I hope there are no problems. So you say D, and then port to be 0, and then the service should be 201 to 3. The banner should be 3. So hopefully there are no problems. And just so that we don't make any mistakes, I just take it up for a spin and then debug it. And oh, there's a problem. Can't we do this? Oh, well, it is not working. Let's just make this very simple. So for D in data and then CV input dot append, we have a tuple of IP and data will have the ports and the banner will be yeah the third index. Okay. Let's see for D. Let's see what D is. Okay, so D0 will be the IP. Alright, perfect, 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 perfect. That is perfect. We should not. So we have CV input being the first one being this. Okay, okay. So that will work and that will give us the final results. So let's stop this. And so after we have our CV input, we will return CV input for the whole work. But for testing purposes, we are going to call scanvons CV input. Alright, scanvon CV input. And then when we come to let's quickly finish this. I don't want this to take long. So for each IP and port in the scanvons, we will call vulnerability check. Have a function here for that. So vulnerability check, all it's going to do is it will just send a request to the website and receive. This will be the limit, how many requests you want to see, 10, 15, 20. 5 is too much, let's limit it to 2. And then we'll call some function print vulns results, print vulnerability results. So okay, I'll copy that function. Wow, so all that this function is doing is, we have the length here. We will check if this length is 0. If there's no banner, then we will just return. Okay, if there's no results in the request that we sent out, we will just return. But if there are results, we will just print out vulnerability set result for the particular IP and the ports, and then yeah, this will now process the JSON file that we receive from the website. Yeah, the results will be in a JSON format, so we just process it and then print out the results, and that is about it. Let's run this scan once. Let's put a breakpoint here and check what happens. Hopefully there's no results, there's no error. Okay, so let's step into it. So we initialize our CVE check, no problem so far. The API status is true, so no problem. And then for IP ports, this text is empty. This text is empty. So if text is empty, just go back. We don't need to send any API request. So the next one, this we have a results. This will not. It is not good to send this because I don't know, maybe we'll get a results or something. Let's see. This I don't think we will get anything. It's, there might even be an error. Since it seems we have, oh, there is an error. Color table not defined. Okay. Thank you. Color table not defined. So you'll need to import a couple of things here. So from pretty table dot color table import color table and the theme, comma, and the themes, and then from term color import colored. Right. This is the function used to print out the colors. There are some. Well, let's run it. Okay, so you run printer.py again. Let's step into it. Okay, no problem so far. I will send this out there. Okay, even though I don't know, but we got something. For this. That's, I don't know what. So seeing an exploit, the results is really messy. 0-day unauthenticated remote SCH overflow exploits. I don't even know what that is. Obviously, we will need to do something about this output. I don't like it. It's too messy. But we will do something about this. Okay, so now we are going to check for. Let's just print out text. So we are going to check for FTP. Hopefully we get nice results. Very nice, helpful resource. Alright, okay, so if I expand it, it looks pretty nice. We got only one response back, even though we wanted two, but at least we have something. Okay, it's telling us some of the possible exploit that we can use. Okay, so and so that was pretty much it. Let's just run everything. So no noise. Okay, so for some of them, no known exploit was found. For this, where are you? Oh, we got it. Where are you? You got something, but it's not helpful because the banner is not helpful itself. So uh, for some of them, we got no exploits. Yeah, that is it, guys. That is it. If you are able to, if you're able to tune the banners correctly, you will get very valuable resource to help us in the subsequent tests. So stay safe, guys, and thank you for sticking around all this while. See you. Bye bye.